Hello, class. Today is the 17th, which is a B-Day, which, as we know, is going to be asynchronous for us. As such, I'm making this video, as I have done many times before, just to sort of get us prepared to get into this next lesson. This next lesson is lesson 14. We're skipping ahead one lesson. It's because I kind of feel like lesson 13 was a little redundant and didn't really teach us anything new. And, as I say this, we look at lesson 14 and we look at our opening exercise, and it says divide 1/2 by 1/10 and use a tape diagram to support our reasoning. But that on its own is already just review. Why are we doing this? Well, because we're going to be using this opening exercise to lead into some things that we do later on. So, hopefully you'll bear with this short recap. So, to divide 1/2 by 1/10, what I want to do for this is, well, personally, again, I like when I'm drawing a model, I like doing partitive when it comes to drawing my tape diagrams, especially since it says tape diagram. And remember, partitive means that 1/2 is 1/10 of what? I need to know what 1/2 is a tenth of. So that means for my tape diagram over here, I'm just going to draw one long continuous shape. I don't know what the whole size of this is, but I do know that if I take this and I split it up into 10 pieces, just like that. If I split it up into 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then I know that one of these pieces, at the very least, is 1/2. So if I know that 1 out of my 10 pieces is 1/2, then I know that if I take my 1/2 and I multiply it by 10, I should get what my whole is. And if I do 1/2 times 10, well, that's going to give me 5, which means that 1/2 divided by 10 is going to equal 5. And it tells me to relate this model to our invert and multiply rule, which we've gone over a couple of times. If I have a division problem like this of 1/2 divided by 1/10, what I can do with my invert and multiply rule, I keep my first fraction the same. I invert or flip over my second fraction, and then I change it from division to multiplication. So when I do this, I get 1 times 10 gives me 10. 2 times 1 gives me 2. So I get 10 divided by 2, or otherwise known as 5. And we can see right here, this 10 over 1 is the exact same as just if it was 10 on its own. So this step right here is the exact same as this step right here. 1/2 times 10 over 1 is the exact same as 1/2 times 10 without it being over 1. They're the same thing. But what if, and this is where we get into our new things, what if instead of deciding to go with fractions for this, I instead decided to take these fractions and turn them into decimals? Well, let's look at that. 0.5 divided by 0.1. Now, if we look at these, this is literally the exact same as what we've already done. And we can once again do this as a partitive diagram, especially since it's asking us for a tape diagram. If I want to do that, I'm going to draw this large shape. I don't know what the whole shape is, but I know that if I split it into 10 parts, one, two, three, four, five, six, 7, 8, 9, 10. I know that one of these parts is going to be equal to 0.5. Because 0.1, I need 10 of those to make my whole. So I'm going to take 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Because 0.1 is just 1/10. So now, well, I do basically the exact same thing. If I know that 0.5 is 1 unit, I need to take my 0.5 and multiply by 10. And then when I'm multiplying something by 10, especially when it comes to the decimal, big thing that I could just do is I could take my decimal and move it over 1. And that's going to give me 5, which, as I'm sure you'll see, is the exact same answer that we have up there. And doesn't that make sense? Shouldn't we get the same answer? I mean, we're using the same numbers, except up there we were using fractions, and down here we're using decimals. So we should get the exact same answer. It makes sense. So up next, it asks us to rewrite 0.5 divided by 0.1 as a fraction. Now, hopefully we remember this. But if I want to rewrite a division problem as the fraction, that means I just take my dividend, my first number, put it as my numerator, and take my divisor, my second number, and put it on the bottom. That's it. So I've taken 0.5 divided by 0.1, and I've written it right there as a fraction. The last part of example 1 tells us, well, we want to express our divisor, our second number, the 0.1, or our denominator, if we're talking about the fraction. Want to express that as a whole number. I don't want it to be a decimal anymore. So, well, let's do that. If I wanted to take 0.1 and I wanted to make that into a whole number, well, how would I do it? Simple. Because I have my 0.5 over 0.1, and if we remember correctly, think, if I want this to be a whole number, well, all I'd have to do is move my decimal once. I have 1/10, because remember, my first number past that decimal is tenths. So to get rid of that 1/10, what I'm going to have to do is I'm going to have to multiply my denominator by 10. And that means that my denominator is going to become a whole number. It's going to be 1. But this is something that we've gone over for a while now. If I multiply my denominator by a number, I'm going to have to take my numerator and I'm going to have to multiply it by that same number. So if I multiply my denominator by 10, I'm going to have to do the same with my numerator. So my 0.5 times 10 is going to give me 5. And then 5 over 1, wait a minute, anything over 1 is just whatever I have in my numerator. So that's 5. And again, it should make sense that we're getting 5 as an answer here because we're doing the same exact question that we drew up here in this diagram. In fact, taking our 0.5 times 10, that's the exact same thing that we did in our diagram in the first place. So when it comes to dividing a decimal by another decimal, what we like to do is we like to make it so we don't have a decimal in the first place. So for example, if we go on to exercise 1, well, the entire bunch of exercises 1 through 3, it says, well, convert the decimal division expressions to fractional division expressions in order to create whole number divisors. We don't want our denominator, our number down here, to be a decimal anymore. We want it to be a whole number. So it says, well, the first exercise already been done for us. So we're going to sort of look at this. We have 18.6 divided by 2.3. Well, I'm going to take that and I'm going to change it directly into a fraction. It changes this from written as a division sentence to written as a fraction of 18.6 over 2.3. But I don't want 2.3 in my denominator. I want my denominator to be a whole number. So this, since it's 0.3, those are my tenths, so that I can move my decimal one place and I'll get a whole number. So I need to multiply both my dividend and my divisor by 10 in order to get 186 over 23, and then we could take that and change it back to a problem like that. So now it's our turn. I have 14.04 divided by 4.68. Well, again, what I want to do first is I want to take this and I'm going to change it into a fraction. I've got to put my decimal place in. 14.04 over 4.68. So now, instead of having dividend and divisor, I have numerator and denominator. But, again, they're the same thing in this scenario. So what am I going to have to multiply my denominator by to change this into a whole number? It's not going to be 10 because multiplying by 10 moves my denominator once. I need my denominator's decimal to move twice. So it needs to go 1, 2. So, in order for it to move twice, instead of multiplying it by 10, I'm going to multiply it by 100. Which means I also need to multiply my top by 100. Because whatever I multiply my denominator by, I need to multiply my top by. Because if I multiply them both by the same thing, then it's not going to change the actual value of what I have. In the end, I'll still get the same thing. Because 100 over 100, that's just going to be equal to 1. And anything times 1 stays the same. So, moving this over 2 decimal places, I end up with 468 on the bottom. And I can do the same on the top. If I move my decimal place over twice, I have 4,004. No, not 4,004. 1,404. I wrote it correctly, said it incorrectly. So, well, why did I do this? Why did I multiply them both by 100? I multiplied by 100 to move the decimal twice. To move the decimal two places. And you might be wondering, well, why not just solve it from here? We're at the point where we could solve it if I really wanted to. But, well, that's not what it's asking us for us to do. It's just asking us to take our divisor and change it to a whole number. We don't need to worry about actually dividing this one. Not for this, at least. Lastly, we can look at part 3. Well, this one's actually going to, again, be pretty simple. 0.162 over 0.036. Well, how many times is my decimal going to have to move this time? 1, 2, 3. So, what am I going to have to multiply it by? Well, I'm going to have to multiply it by, well, I can't multiply it by 100. That only moves my decimal 2 points. I'm going to need to multiply it by a whole 1,000. Because multiplying by 1,000 will move it 3 decimal places. If I needed to move it 4 places, I multiply by 10,000. If I needed to move it more, then it would be 100,000, then 1,000,000, then 10 million, and on and on and on. But again, I need to multiply my top by the same amount. And then moving it 3, 1, 2, 3, I could write 0,036, but are those zeros needed anymore? No. A zero that's not around a decimal point, it doesn't matter in this case. Leading zeros in the front like that don't really matter to me. Because 0,036 is the same as just 36. It's the same thing. Same thing is going to come up with this one too. I moved the decimal 3 places. So it would normally be 162, but that 0 in front doesn't make a difference, so it's just going to be 162. And why'd I multiply by 1,000? Well, same reason why I multiplied by 100 in the last one. I needed to move my decimal 3 places in this case. So since I needed to move it 3 separate places, I needed 1,000. Now, with example 2, this is where we start to get into actually solving them. Now we have 25.2 divided by 0.72. So, well, first things first, let's change it into a fraction. I have 25.2 as my numerator, and I have 0.72 as my denominator. Well, what am I going to have to do for this one? Well, I don't know why I'm pausing for effect, giving you guys time to think. But hopefully you should see at this point, I'm going to actually even just erase this equal sign. We don't need it yet. what I'm going to have to do is, well, I need to move my decimal point one place, two places. So as we discussed, moving it two places is going to be multiplying it by 100. And if I multiply my denominator by 100, I need to multiply my numerator by 100 as well. Denominator's super easy. Moving it over twice, that gives me a denominator of 72. Numerator is going to be just a tiny bit trickier. Just a little bit trickier. Because, well, I only have one place to move it. But I need to move it two places because I'm multiplying it by 100. So let's change what I have up here to, instead of being 100, what if I change it to 10 times 10? That'll help us out a lot. Because first I multiply it by 10. So I move my decimal place over once and I get 252. And then 252 still needs to be multiplied by my second 10. And multiplying that whole number by a 10, well, that's super easy. That's just going to be 2,520. Because when I multiply a whole number by 10, I just add a 0 to the end of it. But here's the thing. This extra step that I just did there wasn't actually necessary. It was sort of to prove a point. Because, let me tell you, 25.2, not 2.52, 25.2 is actually 25.20. It actually has zeros going on forever if I want to. But the best way, since I need to move it over two decimal places, is just, well, I only had one decimal place to move over. Just put a 0 there to let me know that after that there's still going to be a 0. So now I have 2,520 divided by 72. Well, now we can actually divide. I'm going to change this back to an actual division problem now. I've got 2,520 divided by 72. Now that's a little bit of a tricky-ish problem for us to solve. So we're going to have to use a little bit of long division to help us out. So I'm going to have my 72 on the outside. Let me give myself a little bit more space. I'm even going to change the color. My 72 is going to be on the outside. I'm going to zoom in. And on the inside, I'm going to have 2,520. So let's go about this step by step. Obviously, first things first, 72 isn't going to go into 2. That's the obvious part. 72 also isn't going to go into 25 any bit. So I can place an X up there. But what about 72 going into 252? Well, it will. It certainly will. But I don't know off the top of my head how many times it's going to go into 252. So over here on the side, I'm going to just count by 72s. So I have 72 first. Then I have 144. Then I'm going to have 216. Then I'm going to have 288. And wait, 288, that's too far. I've gone past 252. So it's not going to be 4. It can only go in 3 times. And what is 72 times 3? Well, we just found it out. It's 216. So I take away 216 from my 252. And what is 252 minus 216? Giving you guys a little bit of time to find this on your own. It's 36. Wow, you're right. It's 36. And then I look at this and I'm like, okay, well, 72 doesn't go into 36 any bit. So now I need to pull down this 0 that I have here. And I need to see how many times 72 is going to go into 360. Okay. Well, I haven't found 360 yet, and I haven't gone past 360 yet for any of these numbers here. So let's keep counting. After 288 is going to be 360. And oh, well, I can make that 0 look a little bit better, but would you look at that? 360. Well, then that means that 72 goes into 360 5 times. And in fact, it goes into 360 exactly 5 times. Meaning I have absolutely no remainder whatsoever. My remainder over here is 0. Boom. Done. So the answer that I got for 2,520 divided by 72 is 35. Which means that my answer to 25.20 divided by 0.72 is also equal to 35. And we can test that. We can make sure that that is the correct answer by checking our calculator. I'm going to grab my phone right here. I'm going to open up my calculator and I'm going to check my work. So if I do 25.2 divided by 0.72, what do I get? Well, hopefully it focuses. I get 35. So I just checked my work on my calculator. We got the right answer. All we had to do was take our divisor, our second number, or our denominator, when we change it into a fraction, and change it into a whole number. Because we know how to divide whole numbers. So, if we have to divide decimals, let's just say, no, we're not going to divide decimals. We're going to divide whole numbers that just happen to give us the same answer as if we were dividing decimals. So, well, I'm sure that some of us are sitting here and being like, well, I want to practice this. I don't want to just sit here and have you tell me what to do. I want to do this on my own. Oh, then go right on ahead. So in this lesson, there's examples 4 through 7. 4, 5, 6, and 7. And then there's example 3. But we'll touch on example 3 in the future. It just takes what we've been doing and puts it into a word problem. So we'll touch on that a little bit. But for now, your classwork to do right now all on your own is exercises 4 through 7. Go ahead, get started on those, get them finished, and I will see you all tomorrow. Hope you guys have a great day. Again, as per usual, if anybody has any questions whatsoever, send me a message on Schoology. Let me know you need help. I'll be available the whole time. of our asynchronous class time. Have a great day. I'll see you all tomorrow.